Wonderful. So, hi, I'm Joshua Elliott. I'm the chief scientist at Renaissance Philanthropy and a director of a lot of our climate portfolio, specifically our ARC initiative and our Climate Emergencies Forum, which I'm going to talk mostly about today. Before I do that, and before I introduce the title of this talk, I do want to say that we are also philanthrocapitalists, just because it's apparently essential that we do that during this session, and I was not told in advance that that was a requirement. Fortunately, you heard Matt Cullinan's talk, which was a clear example of the philanthrocapitalism that we're advancing at Renaissance, and we're also advancing lots of other solutions like geologic hydrogen and a startup accelerator for venture-backable startups and human system resilience. So just wanted to establish my philanthrocapitalist threads before I then go into a tear on completely non-capitalist-based philanthropy. Apologies. Okay, so I want to talk about the Hail Mary phase of climate change. So everything that we do at Renaissance is first and foremost grounded in the acknowledgement that we are nowhere near on track. We're not on track for 1.5, and we're not even on track for 2 degrees. 1.5 is literally physically impossible at this point, especially when we consider that the aerosol pollution from our fossil fuels is masking almost a half a degree of warming that's going to be realized as we decarbonize. The truth is that we actually live in a near 2-degree world right now, but we've just been performing one of the dirtiest and most inequitable forms of global geoengineering through the sulfur aerosols from our fossil fuels. 2 degrees might not be physically impossible, but it's increasingly implausible. With the smart money now, betting on a 3-degree C world or worse. Big banks are stress testing their portfolios against this, and investors on Wall Street are long on air conditioning stocks, believing that demand will skyrocket, which is probably true. To put 3 degrees in perspective, that's about the difference between the last ice age and today, except going in the opposite direction and moving about 100 times faster. And worse still, these scenarios generally make linear assumptions about the stability of natural carbon stores and warming-induced emissions in places like the Arctic tundra. But the more that we, quote unquote, overshoot that 1.5 degree, hopefully safe climate target limit, the bigger the risks are of things like tipping points and feedback loops and cascading systemic risks in the climate. The fact is that we've grown accustomed over the decades to calling climate change a slow motion disaster, but scientists have been warning for many years that that will not always be the case. There are sort of many different stable states within the Earth's system, including extremely unlivable future states, such as the hothouse Earth scenario. Our emissions are currently pushing us towards these unlivable states, and it's really not totally clear whether or not we're going to be able to get back on that stabilized trajectory. The fact of the matter is that climate change is no longer linear. We are not in the non-linear phase of climate change. And so our climate action plans can't be linear either. We need to significantly increase our ambition. We need to bend the curves aggressively. We need to hit the long balls. And yes, we need to throw the Hail Marys. Had to tie that in somehow. At Renaissance, we are advancing a lot of what we think of as big swings within the climate space, including the program that Matt talked about earlier. In the space of catastrophic climate risk, or climate emergencies as we call it, we have been conducting a number of different programs to really build the global architecture for climate emergency action. So this takes the form of 2 different sort of sister initiatives. One called the Advanced Research for Climate Emergencies, or the ARC initiative, which is really the translational R&D engine for creating the programs and finding and training the scientific talent to be able to build programs that can prove or disprove the safety and efficacy of particular technologies around interventions within particular parts of the climate system. And I'll talk more about that. And then the second one is what we call the Climate Emergencies Forum, which is trying to build the institutional global architecture for global and coordinated action that can actually lead to effective plans and actions to avoid catastrophic climate risk. Just some examples of just a few of the programs that we're building in ARC, from trying to stabilize the West Antarctic ice sheet to avoid catastrophic sea level rise, to try and cool and stabilize the Arctic to avoid the many different risks that exist in the Arctic from its massive accelerating warming. Our sulfur tracking program, which is building the first global data set of high-resolution sulfur sources to try and solve that tropospheric aerosol problem. And then sometimes thought of as our craziest program, which is a program to figure out where and how much we can reflood inland depressions as a way of reducing sea levels by creating new seas. It turns out not to be that crazy, and we're going to be launching the program based on that early in 2026. So I frequently get asked, particularly within philanthropy, with so many different risks and things, how do we actually prioritize the things that we choose to work on? And so we've been trying to encode and describe and formalize some of the frameworks that we use internally for this. And we're going to be refining those and publishing them in the next few months. So I just want to run through a few different lessons that we've learned in the context of philanthropy and how we're trying to actually use those to create the kind of frameworks that create a consistent and scalable philanthropic model for addressing catastrophic risk. So the first is fairly obvious, is an impact, urgency, neglect, and tractability framework to actually evaluate the different risks that we see out there in different Earth systems and what we need to do about them. Unfortunately, when you rank the different Earth system risks that we track against this framework, what you find is that it's very, very difficult to find any risk that doesn't score a 4 or a 5 on impact and urgency and neglect. And because of that decades of neglect, that doesn't score better than a 1 or a 2 on tractability. So because of that, we started thinking about it in a different way, trying to really think about a return on investment from early innovation funding and early R&D on specific technologies and the specific portfolios of technologies and interventions that might be able to reduce these risks in this system. Sometimes I call it return on philanthropy or return on innovation. So to put this in context, mitigation is a mature sector now that receives $2 trillion in funding, as Matt showed, largely from market rate investing, with an ROI of about $30 to $50 per ton of CO2 avoided. Adaptation gets hundreds of billions from nations and multilateral development banks at about a 4 to 10x in terms of costs avoided from climate impacts. Carbon removals, as many people know, is a much more nascent sector, but still receives billions in investments from nations and investors, although the trends there are not so great. The entire field of climate emergencies, by comparison, gets something like millions or perhaps $10 million a year, despite the fact that analysis has consistently shown that the return on investment from these interventions is 100 to 1,000x higher in terms of both avoided warming from albedo changes or reduced emissions, and in terms of avoided costs from climate damages. So I won't go into this. I'm happy to chat about this later, but I don't think I have time to go too much into it. But we're doing deep analyses on specific technologies like ice stabilization, Arctic cloud thinning, and global SRM, and many, many others to put this together. Really quickly, some other lessons that we've learned from philanthropy in doing this. You can't just allocate capital into a field that doesn't exist yet. Sounds kind of obvious, but a lot of people don't quite grok that. We have to actually source the talent. We have to co-develop these ideas. We have to train scientists to be able to run complex coordinated R&D programs, and that's all the kind of stuff that we do in ARC. And we also have to actually fund the legitimacy. We have to build the global institutions. We have to build the coordination networks to allow for that. And then finally, I'll just end with this. Maybe this is my call to action. The UN framework for climate action right now has 3 legs: cut emissions, adapt societies, and remove carbon from the atmosphere. Anything that cannot be avoided with that framework is put into a ledger item called loss and damage. Loss and damage is expected to cost the world as much as $400 billion a year for the next few decades. But loss and damage means island nations erased. It means whole coastal megacities redrawn. It means tens or even hundreds of millions of people displaced from their homes. Treating this as a line item in a ledger, particularly one that Western countries will never actually fully fund, is the real moral hazard in the climate action space, not whether or not we do research to try and advance solutions around geoengineering. The fact of the matter is that there is no stable, consistent theory of change for a safe and equitable climate future without a 4th leg in this framework, which is prevention, preventing catastrophic climate impacts from occurring in the first place. So our mission at Renaissance is in the next decade to be able to create scalable, science-backed, and socially legitimate options so that governments and multilateral institutions have the tools that they need to be able to address this problem, turning catastrophic risk from an unmanageable unknown into a governable frontier. Philanthropy cannot do this on its own, but it has a unique role to play as the catalytic risk capital that can build this field, that can demonstrate and de-risk the different technologies, and build the social legitimacy to enable us to transition this ultimately to large-scale government funding. Thanks. And sorry, it's depressing.
Thanks, Josh. Very sobering indeed. I think we have time for one question. Yeah.
Thanks very much for your talk. You hinted at 2 interventions like SRM and filling inland depressions without saying too much more. Can you just elaborate a little bit on what those interventions could look like?
Yeah, so I mean, global SRN is probably the one that people are most familiar with in terms of usually stratospheric aerosol injection or similar. It's also the one that's attracted the most substantial funding, probably about $300 million in the last 15 years, and increasingly recently from tens of millions of dollars from actually investors, largely in the new startup Stardust that many people have probably heard about. So I mean, it's largely like that one has significant momentum, and my position that is largely going to happen, which is why actually at Renville we don't spend a lot of time working on it. We spend more time thinking about, because global SRM is not a silver bullet, how do we actually address the things that it's not going to solve, particularly in the cryosphere and at the cryosphere ocean interface, where increased heat and energy in the ocean has already, in many cases, potentially crossed the kind of tipping points that are going to lead to cryospheric destabilization. The other one, inland sea roof flooding. So we released a report, which I can share with you during New York Climate Week, is a 110-page report detailing like all of the different inland depressions around the world that could potentially be reflooded. It turns out that if we could actually flood them all, which there's a lot of like geopolitical and issues that might make that a challenge, but if we could actually flood them all, we might be able to reduce sea levels by as much as a half a meter, which is enough to save tens of trillions of dollars worth of avoided damages. We probably won't be able to achieve that. The Caspian Sea, you'd have to drill a canal through like 8 different countries to refill the Caspian Sea, which would be a little bit of a challenge, but who knows? If things get desperate enough, we might actually do it. But there are some really low-hanging fruit. The Qattara Depression in Western Egypt, which would by itself hold 1,000 cubic kilometers of water, is like 50 kilometers from the Mediterranean. The Egyptians have actually wanted to refill it for a long time, mostly for hydroelectric power generation, and because it would cause improved local microclimate effects, including increased rainfall across northeastern Egypt and into the Sinai Peninsula. But they just can't get like the international support and the effective loans at the right cost of capital to be able to do it. So a big part of what we're going to be doing over the next year is doing the kind of analysis necessary to try and unlock things like World Bank financing and climate adaptation financing to help them to do that. Yeah.